Hello, welcome back to CS 128 Honors. This is Lecture 7 covering slice types. So today, first we'll cover slices, then we'll cover their application to strings, which they're very closely related to. So, arrays and slices. An array, denoted Tn, where T is the type and N is the length. For example, here we have an integer array, type I32 with length 5, declared right here. These arrays live on the stack. In a previous lecture, we covered the difference between heap and stack memory. These live on the stack. A slice, denoted ampersand bracket T, is a view into an array, or a contiguous collection, like an array. This view is an immutable borrow, which is why it is denoted by ampersand. The original collection can be anywhere. It can be on the stack or it can be on the heap. And the size does not have to be known at compile time. You just have to reference a slice here. You need to reference a collection here. So vectors and slices, they work very similarly. Slices can borrow from a vector just like they can borrow from an array, even though vectors are mutable and they can be variable sized. They're stored on the heap as opposed to the stack. The slice would work the same for the vector as it would for the array, since it's an immutable borrow. So here's an example of what a slice looks like. Here you have the original here is the original X, which stores this is the essentially array in memory. X is the vector that stores a pointer to the array on the heap. This is heap memory. Then here, the length, it stores the total length, and it stores the capacity. So it stores the max length that this vector can have before it needs to resize. A slice is just like this vector here, but it doesn't store the capacity. It doesn't manage anything about the memory. It's just told where it looks and how far ahead it can look from there. Like for example, it is told to look at index 0, and it can go with a length of 5, so up to 4 after the first element it's been told. We can even tell it a shorter length, like here. This, for example, X slice, we refer to the pointer, we borrow X here. So since we don't tell it something to borrow, it borrows the entire length of X. Here, we give it a range, so 1 to 4 exclusive. If we wanted to do inclusive, we would do 1 period equals 4. This would give you 1, 2, and 3, which is why it has length 3. So this one, it starts at 1, and you have access to it up to these values right here. But here, since you're still using X slice after, you can no longer mutably borrow the vector. You cannot do this, since this is an implicit mutable borrow behind the scenes. So strings, which we talked about earlier, these actually work very similarly. An ampersand string is an immutable borrow to an array of characters, which is how it works in C. In C, a string is just a pointer to an array, or it's a pointer to characters, which is an array. A string variable of the string class is mutable. It works more like a vector. And these are some examples of ways you can initialize either of these. So here we can revisit them. A string is a collection of UTF-8 characters. It is pretty much a vector of these characters, since it's a variable size and you don't know it at compile time. Here, also called a string slice, this is essentially shorthand for an array of characters. It can either borrow from a string here on the heap, or it can borrow from memory on the stack stored in the binary of the file, just so you can have that string available to you during runtime. And this string can be used to borrow substrings of big strings here. But this type ampersand string cannot be used on a vector of characters, even though it's pretty much the same thing. It's just a manager class for it, essentially. So here's an example. Here you have a string where it's hello CS128 to string. Here you go and borrow the entire length of this string, so it returns as a string slice, an immutable borrow of the entire string. Again here, like the last example, we can use a substring of this, essentially a vector, which we showed in this diagram, just has access to these three. So in the same way, this would only have access to these elements right here. So we have an analog to the heap allocated memory, which is a vector, and we have a string analog to the immutable borrow of this memory. But do we have a type that is like an array on memory, or on the stack memory? Kind of. So you could always just use a fixed array of characters like such, or you could use the string primitive type, which is treated the exact same way. But it's kind of like an array, and it can live on either. Mostly, though, you'll use either this capital string class or a immutable string borrow, since just the class itself is not very useful. So, thank you for listening. This was a slightly shorter lecture today, but some announcements. Homework 5 has been released, and so has MP1. Homework 5 is due in a week from Wednesday, which is tomorrow, and MP1 is due 2 weeks from Wednesday. Thank you for listening.